Welcome back to the deep dive. Today we are taking a really technical plunge. We're focusing on the core engine room of the modern hybrid cloud, VMware Cloud Foundation operations.
It's
And you, our listener, you've given us some fantastic source material here. It's basically the knowledge base for the 3V0-22.25 advanced certification. So we're not just summarizing, we are hunting for those big architectural aha moments.
absolutely. Our mission here is to take 10, pretty complex technical requirements and turn them into these crystal clear concepts, things that really emphasize flexibility, automation, and smart planning.
Yeah, moving beyond just the facts and into the why.
Exactly, into the operational insight.
And the scope here is huge. It covers everything from IT architectures and VMware solutions to planning and design, and then deep into installation, configuration, administration, all the way to troubleshooting. It's the whole life cycle.
And if you zoom out for a second, the big picture with VCF is actually pretty simple. Automate complexity. I mean, historically, building an SDDC, a software-defined data center, was just a nightmare of dependencies.
Oh, yeah.
You were managing different update schedules, manually tracking configuration drift. What we're talking about today is how VCF and SDDC Manager turn those difficult, error-prone tasks into these streamlined, integrated features.
Okay, let's get into it. Segment 1. The quest for operational agility and stability. This is where it gets real, right? How VCF handles day-to-day maintenance. We tend to think of VCF updates as these big monolithic bundles you have to wait for. But what if there's a 0-day vulnerability? Or a critical bug? You can't just wait a month for the next big release.
You can't. And that's exactly where this idea of async patching becomes so valuable from an operations standpoint. It breaks that bundle rigidity.
So how does that actually work? What's the flexibility?
Well, it lets an admin apply very specific updates to individual components. So say just a patch for ESXi or a critical hotfix for NSX. You can apply that one fix ahead of the full VCF lifecycle bundle.
So the big insight here is that VCF is moving from this, dependency chaos to a sort of controlled flexibility. You don't have to check a million interoperability matrices anymore.
Exactly. Async patching gives you that component-level lifecycle management for the really time-sensitive stuff. So you're not a victim of your own rigid update schedule. It shows a real maturity in the platform.
Okay, so agility is great, but it's useless if the upgrade itself, falls over halfway through. So moving on, what's the single most important step you have to take before you kick off a big task, like upgrading a workload domain?
You absolutely 100% must run the automated pre-check utility.
Wait a minute. If VCF is all about automation, why another tool? Why make us run a pre-check? Doesn't that just add time to the maintenance window?
That's a great question, and it really speaks to how high stakes these operations are. An upgrade might touch hundreds of settings, dozens of components. Everything has to be perfectly aligned.
So the pre-check is
Probiotic.
a diagnostic?
It's a comprehensive diagnostic. It validates the current configuration, compatibility, network health, disk space. It flags things like expired licenses or wrong passwords before the system even tries to make a change.
So it's risk mitigation. You're preventing that horrible scenario where you're stuck with a half-upgraded environment and have to roll everything back.
Precisely. It turns a potential crisis into a simple readiness check.
Okay, third concept in this segment. It's a classic IT headache, certificate management. We've all had that panic when a cert expires and a critical service just goes dark. What's the big operational advantage of VCF's automated certificate system?
The biggest advantage is just a massive reduction in manual work, and more importantly, the elimination of high-risk human error. It automates the entire certificate lifecycle across the whole SDDC stack.
The automation part.
Right.
What exactly is it handling for you?
It handles everything. It automates generating the certificate signing requests, the CSRs, it tracks renewals, and crucially, it deploys and installs the new certificates across all the SDDC components automatically.
And that's huge because generating a CSR for vCenter, then one for NSX, then for SDDC Manager, you're just begging for a typo to bring everything down.
It was a recipe for failure. This automation is really peace of mind. It just eliminates one of the biggest, most fragile points in a traditional infrastructure.
All right, let's shift gears. We've talked about keeping a running environment stable, but none of that matters if the foundation wasn't built right. So, segment 2, initial design and commissioning. When you're adding a new host to a vSAN-based workload domain, there's a very strict, almost counterintuitive rule for the host's local disks. What is that requirement?
The disks must be completely blank, and I mean absolutely bare metal. No partitions, no file systems, and this is the critical one, no hardware RAID volumes configured.
But that goes against everything we used to do, right? You'd always pre-stage a server with an optimal hardware RAID. Why does SDDC Manager demand that level of control?
It's a mandate. It's a mandate because VCF and vSAN need to be the absolute masters of the storage. SDDC Manager needs total control over that disk initialization. So vSAN can automatically claim the disks and configure them based on policy.
Ah, so if you pre-configure the RAID, you're essentially tying vSAN's hands behind its back. You're giving the chef a pre-cooked meal instead of the raw ingredients.
Exactly. You lose that automatic control, the host prep will just fail. The software-defined layer needs raw access to the hardware to work its magic. It's fundamental to the whole self-driving architecture.
Sticking with design, let's talk networking specifically, NSX edge placement. To get high availability when you deploy an NSX edge cluster, how does that automated workflow place the edge VMs?
The key word is distribution. The workflow intentionally distributes those critical edge VMs across different physical hosts, and it does that using anti-affinity rules.
So for anyone not deep in the virtualization stack, anti-affinity just means keeping things that do the same job on separate hardware.
Correct. And it's vital for HA. It means a single host failure, or even just maintenance on one host, can't take out multiple edge nodes at the same time. It ensures that network services for that whole workload domain stay up.
So it's high availability by design, enforced automatically. You don't have to worry about an operator messing it up later.
You don't. It's resilient from the moment it's deployed.
Okay, moving into segment 3, let's talk VCF operations, governance, security, and intelligence. First up, security posture. What's the VCF operations feature that's like a continuous security yardstick, constantly checking the environment against industry standard hardening guides?
That feature is called compliance management.
Why is that an operational feature and not just, something you run for a quarterly audit?
Because it's not passive, it's active. The infrastructure is self-auditing constantly. Compliance management evaluates the live configurations against benchmarks like DISASTIGs or VMware's own best practices, and it reports any drift in real time.
So it's continuous.
Continuous automated auditing. It's essential for maintaining a secure and provably compliant posture, especially in regulated industries.
Got it. Now let's talk governance. In a big multi-tenant cloud environment, you need to define boundaries for resources, cloud zones, user access. What's the main element that acts as that primary governance boundary in VCF automation?
The central construct there is the project.
A lot of people might think of something simpler, like a resource pool. Why is the project the fundamental boundary here?
Because projects are designed from the ground up to be the single source of truth for consumption. They're how you manage multi-tenant access, control quotas, and define which cloud zones or regions a user can even see, let alone use.
So it sounds like they're critical for the finance teams, too. A project is the financial unit of consumption. It lets you do accurate showback or chargeback against a specific team or budget.
Precisely. It gives you that clear separation of concerns in what is otherwise a big, pooled, multi-tenant environment. It's what makes the whole thing scalable and accountable.
Okay, let's get into operational intelligence. So many monitoring systems are just noise, a flood of alerts that hide the real crisis. How does VCF operations build smart alerts that only trigger under very specific, multifaceted conditions?
It does that by combining multiple symptom definitions using logical operators.
Can you give me an example of how that works?
Yeah, think of it like a doctor. A single high temperature, let's say a CPU spike, might just be noise. But the system only fires a real alert when it sees high CPU utilization, AND, high disk latency, AND, a specific application metric has crossed a threshold.
So you're building complex rules.
Exactly. Using logical operators like AND/OR, the operational benefit is huge. It dramatically reduces false positives. You improve that signal-to-noise ratio, so when an alert does fire, you know it's real and needs attention.
That's the difference between simple monitoring and actual actionable intelligence. Right. For our final segment, let's look to the future scaling out and forecasting. Concept 9 is about predicting resource needs. What's the VCF feature that lets you move from just watching usage charts to actively simulating new workloads?
That would be the what-if analysis tool.
I love that name. It's so clear. What kind of question does it help an admin answer?
It helps them answer, how many more virtual machines can I add before my memory is totally exhausted, or before storage capacity is gone? It calculates the exact limit.
So it's more than just seeing a graph at 70% utilization. The what-if tool can tell you, down to the VM, exactly where your ceiling is based on future demand.
That's the value. You can simulate new projects before you commit the infrastructure. It's invaluable for budgeting, for procurement, for making scaling decisions before you hit a wall. You go from being a reactive firefighter to a proactive planner.
And finally, let's go global. VCF Federation. An admin is managing sites in North America, Europe, Asia. What's the main thing Federation's global dashboard gives them?
It gives them centralized visibility. A single pane of glass for inventory and health across all VCF instances, no matter where they are.
So you don't have to log into each site one by one just to see if everything is green.
No more site-by-site dance. The global dashboard aggregates health status, compliance summaries, operational insights. It just massively simplifies global monitoring and management for distributed teams. It's essential for how we run clouds today. As these controls for governance and resource consumption get embedded directly into the software, moving that responsibility from an admin's checklist to the platform's own automated controls, how does the IT architect's role have to adapt? How do you change your design philosophy to really take full advantage of all this automation? That's something to think about as you go deeper into applied architecture.